everyone, I am Nikita Murthy, Faculty of Information Science and Engineering, Maharaja Institute of Technology, Mysore. Today we are going to study a topic, Principles of Reliable Data Transfer. We are going to study a topic called Principles of Reliable Data Transfer. Now, as you know, in the UDP it does not provide a reliable data transfer. What do you mean by reliable data transfer? When a sender is sending the message to the receiver, there is no guarantee that the message that has been sent by the sender will be correctly received by the receiver in the same format. While traveling in the network, the packet may get lost, it may get corrupted also, it may get manipulated, some bits may get corrupt. So, because of all these chances, there is a chance that in the UDP there is a unreliable data transfer. So, what if we want to provide a reliable data transfer? What is the major principle to provide the reliable data transfer? So, for this we will see one example. Now, suppose these are the 3 layers at a sender side, and at the transport layer UDP is the protocol which is running in the transport layer. Now, suppose UDP, when it receives the message from the application layer, what happens here? Transport layer, it may provide a reliable data transfer, it may provide a reliable data transfer, but a network layer, a layer beneath that, it may not be providing the reliable data transfer. Now, as UDP is running on the transport layer, it will receive the application layer and it may reliably transmit to the network layer. That means, it may properly send it to the network layer, but in the network layer IP is the protocol which will be running in the network layer, which is the unreliable. At this case, what happens when the network layer sends it to the receiver? Since this is an unreliable layer, what happens? The packet which has been sent, it may get lost or it may get corrupted during the transmission. As you could see in the diagram, from the application layer, the application is sending a message to the receiver. But just concentrate on the part A of the diagram. In the first part, what is happening? From the application layer, the message is coming, and then through the reliable channel which is provided in the transport layer, it is traveling to the receiver part. But now let us look at the second part of the diagram. There, what is happening? There, from the transport layer, it will send it to the layer beneath that, that is, it will send it to the network layer, which is an unreliable part. So, here to send it to the network layer, it uses different kinds of functions. Here it uses different kinds of functions, defined functions, to transmit to the network layer. What are those? The first one is RDT underscore send. This is one of the function. RDT stands for reliable data transfer. RDT stands for reliable data transfer, and then send means send the required message. Where it is happening? It will receive the data from the application layer and it will send that message to the transport layer. This RDT send, what it does? It will receive the message from the application layer and it will send it to the layer beneath that, that is a transport layer. Next is UDT underscore send. UDT stands for unreliable data transfer. UDT stands for unreliable data transfer. Here what it does, it will receive the message that has been sent by the RDT send and it will send it to the network layer, which is an unreliable layer. Next, third one is RDT underscore receive. RDT stands for reliable data transfer, RCV stands for receive. What it does? RDT receive, this function will receive the message that has been sent by the UDT send and then it will send it to the reliable data transfer layer, that is a transport layer. Next, the fourth function, deliver underscore data. Here what is happening? This deliver data means receive the message that has been sent by the receive function and then transport it, deliver the data to the proper recipient in the application layer. I will repeat it once again. RDT send means reliable data transfer send, receive the message from the application layer, the sender process, and then send it to the transport layer. UDT send, what happens? Unreliable data transfer send, it will receive the message from the RDT send and then it will send it to the network layer, which is a unreliable layer. And then RDT receive, what it does? It will receive the message that has been sent by UDT send and it will deliver the message to the upper layer, that is again a transport layer. And then deliver data, what it does? It will deliver the data that has been sent by the RDT receive to the proper recipient, that is running in the application layer. Here we are considering only a single movement. As you could see in the diagram, here we are considering only the unidirectional data transfer, that means only from the sender to the receiver, only that one directional data transfer we are seeing. But in the reality it will be bidirectional, but explaining that at this point of time would be very tedious and it will be too complex also. As of now, we will just concentrate on unidirectional data transfer, that means only from the sender to the receiver. Under the principles of reliable data transfer, we are going to see one more topic called building a reliable data transfer protocol. Now, under this we are going to see how we can build a protocol which provides a reliable data transfer even though it has some flaws. Here under this we are going to see so many scenarios, so many cases where we will start with the very simplest model and then as we go on we will see the complex ones. As we move to the complex ones, we will try to resolve problems one by one. Under this, the first case which you are going to see is reliable data transfer. Reliable data transfer over perfectly reliable channel. The first case which you are going to see under this building a protocol here, reliable data transfer over perfectly reliable channel. Now, as we know, there is no such thing called perfectly reliable. Even though TCP provides reliable data transfer, we know it does not provide 100% reliable. That means there will always be some network flaws which causes some packet losses or packet to get corrupted also. So, this perfectly reliable channel is very trivial, but we call this protocol as RDT 1.0. We call this protocol as RDT 1.0. RDT 1.0, but this protocol is very trivial. To define how this protocol works, we use finite state machine, FSM. We use finite state machine. You might have seen this in this finite automata, isn't it? In the ATC, your subject, you might have seen this automatas or finite state machines. Here also we are going to use the same finite state machines to know how the sender part works and how the receiver part works in the first case. So, this is how the finite state machine of a RDT 1.0 will look like. This is the finite state machine of a sender. There will be a separate finite state machine for the receiver also. This is for the sender side. So, this is a finite state machine for a sender side of the RDT 1.0. Here this is the state. Here this is the current state which will be showing. Here it says wait for call from above, wait for call from above. That means wait until you receive the message from the upper layer. It says wait for the message from the upper layer. Here what happens, this arrow is indicating a transition. That means when some event is happening, from which state to which state it is traveling, from which state it is to getting changed, that it will indicate. That means here it is shown on a loop, isn't it? That means whatever, if this event has occurred, this state will remain same, it will come back to the same state, the transition is coming back to the same state. Now here what is causing the transition? The event that is causing the transition, it will be shown above the horizontal line, and the event, the action taken because of that event will be shown below the horizontal line. I am repeating it again, the event that is causing the transition, it will be shown above the horizontal line, and the action taken for that event, it will be shown in below the horizontal line. Now here, how do we know which is the initial state from where the finite state machine is started? To indicate that, we show this arrow, dashed arrow. This dashed arrow will indicate this is the initial state. Now, what is the event that is causing the transition? The event is RDT send of data. That means as soon as you receive the message, send it to the transport layer, receive the message from the application layer, send it to the transport layer. And what action has to be taken for this event? That means make the packet, that means encapsulate it into the UDP datagram or TCP datagram, and then create the packet encapsulating the data, and then send it UDT send off packet, send the created packet to the network layer, receive the message from the application layer, and then send it to the transport layer. Of here what happens? Make a packet, encapsulate it in the packet, and then send it to the network layer. Now we will see the receiver side. This is the finite state machine of the receiver side of the RDT 1.0. Here this is the initial state, the dashed arrow will indicate the initial state. What is the state? Wait for the call from below. That means wait until you receive the message that has been sent from the sender. So while the receiving end, what happens? Well, we will receive the message from the lower layer, isn't it? That is why they have said in the sender side we had said above, isn't it? In the receiver side we are saying below, because we are going to receive the message from the layer beneath us. So here wait for call from below, and the transition, after the transition it is going to stay in the same state. Now next, what is the event that is causing the transition? RDT receive of packet. The packet that has been sent by the sender, after receiving it, send it to the upper layer, that means a transport layer. Next, after receiving the packet from the transport layer, what we have to do? Extract the data from the packet, and after extracting the data, what we are going to do? We are going to deliver the data to the recipient process in the application layer. I am going to repeat it again. After receiving the message or that has been sent by the sender from the lower layer, after receiving it, what we are going to do? We are going to receive the message and then send it to the upper layer. And then after receiving it, what we are going to do? We are going to extract the data from that packet. After extracting the data, we are going to deliver the data to the upper layer, that is application layer, where the recipient process is running. The second case which you are going to study under this building protocol is reliable data transfer over a channel with bit errors. Here the second case is reliable data transfer over a channel which has a errors, with bit errors. Here there is a chance that the packet might get corrupted, that means some bits may get manipulated. That means here also even with this case also we are trying to build a protocol which provides a reliable data transfer. Earlier we were calling that in the first case the protocol was called as RDT 1.0, isn't it? Here we call this protocol as RDT 2.0. We call this protocol as RDT 2.0. So, now let us consider an example. I am speaking with my friend over a phone. And while speaking I am saying some information. Let us say I am conveying some information to my friend. That if that information is correctly received by my friend, he has to say that yes, okay, I have received, okay, it is correct. That means he has to give me the positive acknowledgement from his side. That means from the receiver side he has to give me a positive acknowledgement, so that I may be convinced that the message that I have sent, it is properly received by my friend. That means whatever the message that I have conveyed, it is properly received by my friend. That means a positive acknowledgement I should receive. Now suppose due to some network issue, whatever I have said, the sentence which I have said is garbled, it is corrupted and it is not properly heard by my friend. What he will do? If he is not heard it properly, what he will do? He will say, please repeat it again, I did not hear what you said, isn't it? That means he is going to provide me the negative acknowledgement, saying that whatever you have said I didn't hear, please repeat it, that isn't it? That means based on the acknowledgements which I am receiving from the receiver, I am going to know whether the packet that I have sent is correctly received by the receiver or not. If it is not properly received, when he says please repeat what you said, I did not hear, what I will do? I will repeat the sentence which I have said it earlier, isn't it? That means I am going to retransmit the message which I have said. That is why here in the RDT 2.0, if the packets get corrupted, if it is not properly received by the receiver, what it does? It will retransmit the same packet. That protocol we call it as automatic repeat request. Automatic repeat request, ARQ protocol. Automatic repeat request protocol or ARQ protocol. This protocol does retransmission of packets. So, this automatic repeat request protocol will provide retransmission of packets when the receiver is not received the packet correctly. So, ARQ protocol or RDT 2.0 to work to do all this, it has to have few capabilities. What are those capabilities? The first capability is error detection. Capabilities. The first capability is error detection. That means, if I have to check whether the received packet is correctly received or not, for that to happen we should have a mechanism to check whether error has been introduced in the packet or not, whether the packet that I have received is corrupted, if the bits have been manipulated or not. For that to happen, there has to be an error detection mechanism, isn't it? In the earlier section we saw a mechanism called checksum, isn't it? Here also we use checksum. Here also we use same mechanism called checksum to detect the error that have been present in the packets while transmitting. The second capability is receiver feedback. The second capability is receiver feedback. I said earlier that means when the packet is correctly received by the receiver, he has to provide me the positive acknowledgement. That means I will denote the positive acknowledgement as ACK. That means the receiver will say, yes, I have correctly received the packet that I have sent. Now, if the receiver has not received the packet correctly, if it is corrupted, what he will provide? He will say that please repeat the message, I did not hear properly. That means that is the negative acknowledgement. I will denote it as NAK, that is negative acknowledgement, isn't it? When you receive the packet properly, you will provide positive acknowledgement. When you did not receive the packet is corrupted, you will provide negative acknowledgement. That means you will provide the feedback from the receiver. Based on the feedback which you have received from the receiver, based on that we are going to send a new packet, or we are going to retransmit a packet. So, this is second capability. The third capability is retransmission. Retransmission, that means when the packet is not correctly received by the receiver, we should be in a position that we should retransmit the data that has been corrupted. If it is not properly received, we should send the same packet to the receiver again. We are going to retransmit the data again. So, these are the three capabilities which are required, or which this RDT 2.0 has. Now, let us try to look at the finite state machine of the sender side of the RDT 2.0. This is the finite state machine of the sender side of the RDT 2.0. So, let us start with the initial state. Here it says wait for call from above, that means wait until you receive the message from the upper layer. when you receive the message, what you will do? You will send the data to the lower layer. After sending it, what you will do? You will create a packet. You will encapsulate the data into a packet. Not only data, you will also introduce checksum. Already I said we need error detection mechanism to detect whether the packet is corrupt or not. To detect that, we are going to introduce checksum also along with the data, and we are going to encapsulate it into the packet, and then we are going to send it to the lower layer using UDT send. And then when this transition happens, the state here is changing, it is not remaining in the same state, it will go to the next state where it will be waiting for the feedback from the receiver. That means here it is going to wait for acknowledgement, that is it could be a positive acknowledgement or negative acknowledgement. When it receives the positive acknowledgement, a separate event will happen. When it receives the negative acknowledgement, another event will happen. That means first here when it receives the packet, and it is also receiving a negative acknowledgement. That means here when it receives the packet and along with the packet it is receiving a negative acknowledgement, what happens? What action it is going to take? It is going to resend the packet. Here the retransmission is happening. Here it is going to retransmit the data, and then it is going to wait in the same state. Why? Because until it receives the positive acknowledgement, it does not go into the initial state. So, this is responsible for retransmission. And here when it receives the positive acknowledgement, when the packet is received and it is a positive acknowledgement, what it does? It is changing the state to the initial state, and what is the action taken? Here it says nothing. This symbol, this delta symbol will say no action has been taken. Please do note this. Here this symbol will denote no action has been taken. So, this is the sender side of the RDT 2.0. Now, let us try to look at the receiver side of the RDT 2.0. So, this is the receiver side of the RDT 2.0. It has only one state. So, the state says wait for call from below, that means wait until you receive the message from the lower layer. When you receive the message, and that message is corrupt, when you receive the message and that message is corrupt, what we have to do when that message is corrupt? We will send a negative acknowledgement to the sender, isn't it? That is what they are going to do. Here they are going to create a packet of a negative acknowledgement. They are going to create a packet of negative acknowledgement and they are going to send it to the sender. And then, and the packet received is not corrupt. If they receive a correct packet and it is not corrupted, what you are going to do? You are going to send a positive acknowledgement, isn't it? That is what they say. When the packet is not corrupted, they are going to extract the data from the packet and then they are going to deliver the data to the recipient, proper recipient, and then again to the sender they will send the positive acknowledgement. With this, RDT 2.0 is finished. Thank you.